Hey everyone, welcome back to my YouTube channel Knowledge Odyssey.
This is the second episode in the network theory series. In this episode, we are going to discuss about Kirchhoff's laws. Kirchhoff's laws. Kirchhoff's laws are formulated by German physicist Gustav Robert Kirchhoff. Kirchhoff's laws are fundamental principles used to analyze electrical circuits. They provide a systematic way to determine voltages and currents in complex networks. These laws are based on the principles of conservation of energy and charge, and also these laws help calculate the electrical resistance of a complex network or impedance in case of AC and the current flow in different network streams. Now let us discuss in detail about these laws. The first law of Kirchhoff is called as Kirchhoff's current law or KCL. Now according to Kirchhoff's current law, the total current entering a junction or a node is equal to the current leaving the junction or a node. This can also be said in different way. The algebraic sum of the currents entering and leaving any node or junction in an electric circuit is equal to 0. This Kirchhoff's current law reflects the principle of conservation of electric charge, which means charge can neither be created nor be destroyed. Now let's visualize this. In the picture shown aside, there is a node and currents are entering the node and are leaving the node. Let us assume the currents entering as I1, I2 and I3 and the currents leaving as I4 and I5. Now according to Kirchhoff's law, the sum of all these currents should be equal to 0. So the sum of currents entering, which is I1 plus I2 plus I3, and the sum of currents leaving, which is I4 and I5. The currents leaving are negated because they are going out of the node. So now I1 plus I2 plus I3 plus of minus I4 plus of minus I5, which is equals to 0. This is Kirchhoff's current law in precise. Now let us discuss about the second law of Kirchhoff called as Kirchhoff's voltage law or KVL. According to Kirchhoff's voltage law, the voltage around a loop equals the sum of every voltage drop in the same loop for any closed network. Or this can be seen in a simplified way. The algebraic sum of all the voltages around any closed loop in a circuit is equal to 0. This law reflects the principle of conservation of energy, which means energy can neither be created nor be destroyed. So let's visualize this. In the picture shown here, we have 4 resistances and 4 points. So let us assume the voltage between point A and point B as VAB, and point B and point C as VBC, and point C and point D as VCD, and point D and point A as VAD. Now according to KVL, the sum of all the voltages should be equal to 0, which means VAB plus VBC plus VCD plus VDA is equals to 0. So this is Kirchhoff's laws in precise. Now let us look into the application of Kirchhoff's laws. These Kirchhoff's laws are fundamental tools for analyzing any electrical circuit regardless of its complexity. These are used to determine unknown voltages, currents and also resistances. These are essential for designing and troubleshooting electronic devices and systems. And these laws are applied in various fields including power system analysis, electronics design, telecommunications and control systems. In the next video, we are going to discuss about mesh analysis and nodal analysis. So stay tuned.
Please do like, share, and subscribe and turn on the bell icon for more interesting videos.